Hi, my name is Matt Jacobs, and this is Lab 2 Magnetic Field of a Bar Magnet. So, for the introduction, the purpose of this lab is to understand the relationship between the distance and magnitude of a magnetic field, and then we're trying to compare measurements to the distance dependence predicted by an on and off-axis equations diverted from the Biot-Savart law, and we're trying to learn how to visualize magnetic fields, the fundamental physics principles of the Biot-Savart law, and the distance dependence equation of a magnetic field. In my results, I found that as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases, the magnetic dipole to be 3.571 am squared, and the n value to be negative 2.7313 meters. So for my assumptions, I said that the x-axis is along with the width of my phone, the z-axis points out of the screen, and the y-axis goes along with the height of my phone. I also said that the magnitude of the magnetic field is proportional to the constant multiply of a power of distance r. For my initial conditions, I said that the initial orientation of I set the initial orientation at distance of my phone, or additional orientation of my phone to find the magnetic north and Earth's magnetic field, and then I said system is equal to the magnetometer and the magnet, and the surroundings is Earth's magnetic field. So for the process, I used a magnetometer app where I determined the magnetic north by rotating my phone until the x-component was close to 0. I aligned the stick along the bottom of my phone so that it ran east to west and orthogonal to the magnetic north with the magnet at the end. I located the magnetometer sensor on my phone by using tape, which found the position of where my x and y components were at their maximum minimum. I found the distance from the magnet to the sensor that produced a magnetic field with an x component of magnitudes 20, 70, 120, 170, and 220. And then lastly, I found the distance d perp where the net magnetic field had a magnitude of a distance 100 μt. So for the data, on the left, the data is an average of measurements at a range of a distance on the on-axis magnetic field, and on the bottom is the off-axis field. And then on the plot, you can see that I found the logarithmic plot by plotting the linearized magnetic field against the linearized distance. And for my calculations, I used distance dependence equations where I found the slope to be negative 2.7313 to be the n value, and it's negative and then for these calculations to make it easier, I'm going to use negative 3 as my n value. And then I found k by inserting e into both sides of the equation. I found that k is equal to 7.1427 times 10 to the negative 7th. And then I used the Biot-Savart law to find the magnetic moment, which is 3.571 amperes meter squared. For my GlowScript code, I first created the magnet at the origin and then found the magnetic moment. I used the Biot-Savart law to create a function for the magnetic field, and then I defined the observation location for the on-axis and the off-axis, and then I coded 2 arrows to represent the magnetic fields on the on-axis, and then 4 for the off-axis, or perpendicular to the axis, and I created an arrow to represent 45 degrees from the axis. And so in the visual, you can see that the orange arrows represent the magnetic field on-axis, while the cyan field arrows represent the off-axis one, and then the purple one is the 45-degree angle. When you compare my experimental and computational values, you can see that they are both very, very close. And the difference for this would be that the 45-degree one ignores the z value, and that any other discrepancies probably are due to human error. So for the what-if questions, for the first question, I said that my results will have a significant error as the Earth's magnetic field will skew my measurements of the magnetic field created by the magnet, and therefore all calculated values would be less accurate. And for the second question, I said that the direction of the fields would be the same but double in magnitude because 2 magnets would mimic a singular larger magnet. And for my sources of error, I said that the human error due to measurement with a meter stick, other magnetic fields may be interfering, and then I may have accidentally bumped into the phone or bumped it around while I was recording my data. Thank you.